The liar paradox is one of the hardest philosophical problems of all to solve. It gets right to the heart of problems to do with truth and to do with logic. Let's take a look. Hello everyone, welcome back to The Attic. We've been talking about non-classical logics, three-valued logics, logics where things can be both true and false at the same time. In this video, we're going to apply some of that to the liar paradox. If you don't know what the liar paradox is, have a look at this video and then come back here. If you're finding this stuff interesting, if you're finding it useful, why not subscribe to the channel, hit the bell icon to get updates. So, did you watch the previous video? If you did, you have already met the liar paradox. I said nothing is true in that video, and that was all I said. So, is that true or false? Well, if what I said was true, then everything in the video was false, including the thing I said. So it can't have been true. It must have been false. But hang on, I said that everything in the video was false. So if the thing that I said was false, then it looks like in fact what I said was true. If it's true, it's false, and if it's false, it's true. Either way, we've got a massive, big, problematic contradiction. How are we going to make sense of that philosophically? This is the problem of the liar paradox. That's what we're going to be talking about in this video. Okay, so we're going to be focusing in on sentences like this. This sentence is false. Once you see a sentence like that and you see that it's paradoxical, a lot of people's reaction is, well, there's something wrong with that sentence. There's something wrong with the idea of a self-referential sentence, a sentence that refers to itself and says of itself something. But if that's the idea, what about sentences like this? This sentence contains 5 words. Well, that's obviously true, right? Count them up. 1, 2, 3, 4, 5. That sentence is true. It's perfectly meaningful. It's got 5 words in it. If the sentence didn't mean anything, how come my reaction to it was to count up the words and go, oh yeah, it does have 5 words in it. It's true. Sentences like that are perfectly meaningful, but it's self-referential. It's a sentence that refers to itself. So it looks like self-reference is perfectly fine. Another example, the first sentence on this page is written in white. Yep, that's true. The second sentence is written in blue. Yep, that's true. The third sentence is false. Right, yeah, that's the liar paradox. But the first 2 sentences made perfect sense. It's very difficult to say that the third one doesn't make sense. Another example, think about all those people on YouTube that spend their time slacking off other people on YouTube. So going, oh, that person in that video, none of what they say is true. Now that makes perfectly good sense. We know exactly what those sentences mean. It just so happened that in the video that I showed you, I was saying none of what happens in this video is true. So the point is, if those sentences make sense in general, then they should still make sense when they refer to themselves. Self-reference isn't the problem with the liar sentence. Rather, it's got something to do with our theory of logic or our theory of truth. Okay, so that's what we're going to be thinking about now. Just to make things easy, let's set things up like this. Here's our liar sentence. L is false. L is a name for a sentence. Which sentence does it name? This one. Okay, so we're saying, here's my sentence L, and the sentence says, sentence L is false. So L is a name for this sentence. That's something we can do in English. We can give names to things. I can give a name to any particular object. I can give names to sentences. I can give a name to that very sentence. You might wonder whether that's the kind of thing that we can do in a logical language, in a formal language. Turns out we can. All we need to be able to do is talk about the syntax of a language within that very language. Now, we can't do that in the logics that we've been looking at so far. We need a little bit more stuff. If you add a bit of basic arithmetic, then you can code up all the symbols using numbers, and then you can talk about the syntax of the language just using the numbers, and then basically you get the liar problem. Okay, you can express this sentence isn't true in the very language you're talking about. So this business about self-reference, it applies to English and it also applies to logical languages. So what are we going to do about this sentence L that says of itself that it's false? So one obvious option is to say, well, look, if it's a problem for it being true, it's a problem for it being false, let's just make it neither. Let's say that this sentence is neither true nor false. So there we're in the realm of a three-valued logic, like we talked about a couple of videos back. So we'll try and do a valuation where we say sentence L, the paradoxical sentence, well, now it's going to be neither true nor false. Does that make the problem go away? Well, maybe it solves that exact sentence, but it doesn't really fix the problem because we can just change the sentence a bit. Rather than going, this sentence is false, now let's make it say, this sentence isn't true, like this. This is sometimes called the strengthened liar paradox because this one is a bit trickier to sort out. Suppose we do the same trick and we say, okay, let's make this sentence neither true nor false. Does that solve the problem? Well, if we make the sentence neither true nor false, then in particular, it's not true, okay? Things that aren't true or false aren't true, but the sentence says that it isn't true. And if we're saying, yep, it's not true because it's neither true nor false, then it looks like what the sentence says is true. And we get back to the problem we had in the first place. If it's not true, then it is true. If it is true, it's not true. Saying it's neither true nor false, that doesn't really help. Okay, but there is another option we can take within a three-valued logic. We can say rather than making it neither true nor false, we can have a go at making it both true and false. Let's see if that helps out. If we're saying that a sentence can be both true and false at the same time, we're talking about dialethism. This is the philosophical view that says sentences can and are both true and false at the same time. So if you're going to be a dialethist, that is, you're going to say that some sentences can be both true and false in the same way at the same time, you're going to need a paraconsistent logic. So we've met this already when we talked about three-valued logics. A paraconsistent logic is any logic where you deny the explosion principle. That is, you say you can't go from any old contradiction, A, not A, to random arbitrary conclusions, B. Okay, this inference from them to that is called explosion. Paraconsistent logics say explosion isn't valid. So in paraconsistent logics, you can't infer from those premises to random conclusions. Now, there's lots of different kinds of paraconsistent logics, and you might think that this inference is a bad one, so you want to be a paraconsistent logician. You don't have to do that by being a dialethist, by saying that some sentences can be both true and false. Okay, so being a dialethist is one way to go for a paraconsistent logic. It's not the only way, but it is probably the most straightforward, because if you allow sentences to be both true and false at the same time, then you immediately invalidate the explosion inference. Immediately you've got a paraconsistent logic. So when we talked about three-valued logics, we talked about LP, the logic of paradox. So this is the logic that takes as its designated values both truth, classical truth, and the third value, which we called O for other. Okay, so we're thinking of that third value, other, as meaning both true and false. So the designated values of a logic, these are the ones that count when we think about validity and entailment. So when we're defining validity, we mean a sentence that is always one or the other of these. And entailment, we're thinking about whenever the premises take one of these values, then the conclusion also takes one of these values. Okay, so the designated values of a logic, these are the values that matter when we're thinking about validity or entailment. LP, the logic of paradox, it takes both of these values to be its designated values. Why does that mean that the explosion principle isn't valid? Well, it's pretty simple. Just take a valuation on which A takes this other value, O. Well, then not A will also be O. So both of the premises take a designated value. But that doesn't mean that B has to take a designated value. It doesn't mean that B has to be true or other. Just take a valuation on which B is F. So any valuation that makes A O, but B F, that's going to be a counterexample to the explosion inference from a contradiction to an arbitrary conclusion. Okay, so why is it that saying that the liar is both true and false makes better sense than saying that it's neither true and false? Well, as we've already seen, saying that the liar is neither true nor false seems to be in conflict with the content of the liar sentence, right? If we're saying it's neither true nor false, we're saying that it's not true, but the liar is saying that it's not true, so it should be true. So there seems to be this conflict between the semantics that we're giving it and what it seems to be saying. On the other hand, if we say that the liar is both true and false, then we don't seem to get into exactly that problem. Because after all, the thing about the liar reasoning is that we know that if we say it's true, it's false, and if we say it's false, it's true. So saying that it's both gives it this kind of internal consistency, right? Because if it's one, it's the other, and if it's that one, then it's got to be both of them. Now, in saying that the liar is both true and false gives it this internal consistency, I don't really mean that it's consistent, because in saying that it is both true and false, we're basically saying that it is inconsistent. We're basically saying that it's true and also its negation is true. Okay, so it's definitely not a consistent sentence. Rather, what I mean is we can assign it this value, both true and false, such that when we reason about what the liar means, what it seems to be saying, we don't then get into conflict with that valuation. Any reasoning about that valuation kind of just leads us back to saying, yeah, it's true and it's false, so it's both true and false, but that's kind of what we said it is, so there's no conflict there. So in the way that we are doing three-valued logic, we have this third truth value, other, and we think of that in the case of LP as meaning both true and false. So when we're saying that this sentence, the liar sentence, is both true and false, technically what we're doing is we're assigning it the value O for other, and we're reading that, we're interpreting that as meaning both true and false at the same time. Okay, so question for you guys. What do you think of the liar paradox? Is it true? Is it false? Is it neither? Is it both? Or maybe it's something else entirely. If you've got thoughts on that, leave me a comment down below. That is all for today. Thank you so much for listening. Thank you for all your support. If you're enjoying this material, why not subscribe to the channel? It will be great to have you on board. I will see you guys next time.